Okay, it's 1 minute past 1, so we start. So my name is Carl-Erik Hossein, and I would like to welcome you to this webinar about WASP's Industrial PhD Student Call and about the Industrial Postdoc Call 2023. So here you have the program for today. First, Danica Kragic, also a co-director for WASP, will start and give an introduction to WASP. Then I will take over and talk about the Industrial PhD Student Program and also about the Industrial Postdoc Program. And then we switch to Fredrik Heinz, who is manager for the graduate school, and he will talk about the graduate school aspects of this. And then finally, we have perspectives from industry. We have Per Skarin, a former industrial PhD student, and his industrial supervisor, Johan Eker from Ericsson. And then afterwards, we have questions and discussions. So then we hand over to Danica, and I will stop sharing.
So I'm here to give you a general overview of the WASP as a program, and also hopefully inspire you and show you why this is an excellent program to be a part of as a PhD student. So to start with, it's a big national program, and we have 5 founding universities involved in the program: Chalmers, KTH, Linköping, Lund, and Umeå. And also we have 3 affiliated groups of excellence at Örebro University, Uppsala University, and Luleå. Now, to give you a little bit of an idea what WASP is all about and why it's important both from the scientific and industrial point of view, the vision for the program has been to perform or conduct excellent research and build competence in artificial intelligence, autonomous systems, and software for the benefit of Swedish industry. And our mission is to build a world-leading platform for academic research that interacts with leading companies in Sweden to develop knowledge and competence for the future. So I think that both vision and the mission shows you show you the importance of involving special industrial PhD students in the program. Very welcoming. To give you a little bit of numbers also on the size, so it's a huge program, currently having the budget of 6.2 billion Swedish crowns. And it got extended so that the current plan is to have the program active until 2031. And as a part of the program, since 2017, we will be, as one of the goals, educating 600 PhD students and also build groups around 80 new faculty recruitments. Now, how should we see WASP and what is really important? So WASP students and faculty are, apart from doing lots of basic research, providing really enabling technologies that are needed in very many different sectors and types of sectors that also pose lots of societal challenges when we talk about transport and transport system in general, when we talk about energy production, energy distribution, manufacturing, healthcare, IT, and so on. It's extremely difficult today to find a sector where WASP research wouldn't actually come of use. And also WASP is contributing by paving the way for Sweden in then specific areas such as artificial intelligence, autonomous systems, and software. And in relation to that, we have identified very many different research challenges that also align and resonate with many of the international research challenges. So I won't spend all the time now going to the details. But for example, if we start with autonomous systems, these are some examples from going from, let's say, more classical automatic control-driven approaches to now exploiting data-driven approaches and integrating this, thinking of resource efficient distributing, modeling, and execution when it comes to deployment of physical systems and so on, scalability in terms of deploying these systems in different contexts, and having also these systems interacting both with the human and with the environment. When we talk about research challenges in the area of software, we talk about adaptive systems that are aware of a human, both human as a user, but also human in the loop in general, monitoring systems, automated verifications of various types of software systems, and so on. When it comes to AI and machine learning, of course, it's very difficult today to think of almost any area or business where AI could not come of use. But there are very many challenges, and I would say that the whole WASP program is looking very much into how then to use, for example, area of software or autonomous systems also as use cases for then developing responsible, interpretable methods in the area of AI. And to our help, we have a large portion or several groups of people doing research in mathematics of the relevance for AI, where all the then methods that we are developing, we are also trying to understand them from the, let's say, mathematical or basic point of view, and assess them and their challenges, or potentially what works, what doesn't, and so on. So analyzing the properties of various types of methods that are being developed and deployed. Now, there are many instruments. As I said, it's a huge project. So apart from the, of course, conducting excellent research through faculty and PhD students, you will also hear during today a little bit about the graduate school. We are making sure that we are also recruiting continuously excellent people that we can integrate with the ongoing activities, and recruitments are of course done internationally. We are looking very much into how we can find ways of bringing the academic research closer to industry, and also industrial needs closer to the academia. And this is why we have so-called research arenas, large-scale experimental venues, I would say, where the industry and the academic research that comes closer together. We also have various types of instruments that allow us to both host people from leading international institutions, but also send our students and faculty as guests to those excellent international institutions, to both initiate or continue to perform collaborative work in order to also make WASP outcomes visible internationally. And we are working our best to communicate everything we do, and our gathering today is also one of such an event to communicate what and how we are doing. What is also important, and what I said, that many of the areas of the research that are covered by WASP are also of interest for other sectors, and voluntary foundations are so nice to help us to also collaborate or find ways of collaborate with other areas. So one recent collaboration that has been established is between then WASP and researchers from life sciences, called Datadriven Life Science, which is also a long-term project that, as I said, started last year and will continue to grow through collaboration and through collaborative projects. So it's very likely that some of the industrial PhD students will also be coming from companies that are maybe not the usual, let's say, players that we are used to see more in the technical areas. We also are just on the way of starting a big collaboration with Wallenberg initiative in materials science for sustainability, which is called WISE, and will be starting from 2024. But now we are in the period of planning of how we can also collaboratively exchange some of the challenges and where research from WASP can come of use to help people in the material science to embrace some of the methodologies that we are developing. And the third one is another initiative, very important, maybe much closer really to WASP than those previous two that I just presented, is cybersecurity initiative, where we look how we can both, let's say, gather the excellent research in cybersecurity that already exists in Sweden, but also through the networking and all the experience that we have with our international partners that we already established through WASP, can also help and strengthen this particular area nationally.
Okay, the industrial PhD student call. A Swedish PhD education nominally is for 4 years at 100% level. Normally one do it at 80% level, and the remaining 20% you either spend teaching if you are a university PhD student, or you spend working at your company if you are an industrial PhD student. So 4 years corresponds to 240 high school credits. Out of these 240 credits, all the PhD students are required to take between 60 and 120 credits in courses. And the amount varies. Right now, I would say that most departments have 90 credits. Some computer science departments have 60, and maybe a few math departments have 120. So 90 credits corresponds to 1.5 years of full-time studies. Normally, the departments, they have their own rules about which mandatory courses the students have to have. And then WASP has its rule about which mandatory courses that the student have to take. And currently, these courses correspond to 27 credits out of these, let's say, 90 credits in total. And the rest, 240 minus 90, then constitutes the actual research and the production of the PhD thesis. So that's a standard PhD education. If we look upon the WASP Industrial PhD student program, then the students are employed by a company. So they do their PhD studies at the university department that belongs to one of the WASP universities. If you do this on 100%, it's 4 years, but normally one do it at 80% level, means that you do it during 5 years. For this, the company receives 600,000 Swedish kronor per year from WASP if the studies are done 100%, or 480K per year if it's done at the 80% level. This includes a travel budget of 30K per year. And it's important that the student is allowed to travel. So even if the company has a travel ban due to bad economy, for instance, the PhD student should still be allowed to travel. Then in addition to the funding that goes from WASP to the company, the university also gets funding. So the academic advisor gets funding that corresponds to 15% of the salary for this. The PhD student has one university PhD advisor and one industrial PhD advisor. Ideally, this is also a person with some research experience. Often it's a person who already has a PhD, but not always. Then there is also the rule that the student must spend at least 20% of the time physically at the university and at least 20% physically at the company. However, in practice, spending only 20% at the university is not enough. So I would say that 50% at the university is probably the minimum in order for this to work in the way it should. Then there is a contract that is signed between the university and the company. No contract between the company and WASP. The there should be an individual development plan for the student at the company that details things like what is the main contact person, the industrial supervisor, the role of the closest manager, the role of the project in the overall company strategy, how the company should pick up all the new research that the PhD student develop and so on. And then at the university, there is an individual study plan that details issues such as time spent, research results obtained, and so on. And that is just in the same way as ordinary university PhD students. They also have the individual study plan. Okay, so right now in WASP, we have 102 active industrial PhD students coming from 46 companies. We have 23 industrial PhDs that have been that are finished. 3 of them decided to end after licentiate exam. Licentiate, that's the Swedish midterm exam to PhD. Some companies have a very large involvement, like Ericsson, Saab, Zenzact, ABB, AstraZeneca. But most industries have only 1 PhD student each. Due to the statutes of Knut Annelies Wallenberg Foundation, who funds WASP, research institutes, for instance, RISE, and public organizations, they may not participate directly. So there cannot go any funding from WASP to these organizations. And as Danica hinted at, it's not only traditional systems and industry that can participate, but also fintech, media, health, life science companies. As long as the, so to say, element of autonomous systems, AI and software is sufficiently high in the project. So this call is nominally for 15 positions. It opened 16th of January and it closes 7th of April. The WASP board communicates the decision by the 3rd of June. The earliest start date is 1st of August. And the latest start date is 1st of January 2024. This is very similar to how it has been the last calls. You submit your application through the WASP application portal, and there you find all the forms and things you need to know. It's important to know that the application should be signed by both the academic supervisor and the industrial supervisor. Okay, so that was the formality, so to say. What should then the application focus on? Well, it should focus on something that lies within WASP's area, WASP research area. And here is, one can say that we have 4 different areas. The first one, the one that is the oldest one, is autonomous systems, AS. And there one do research on different aspects of autonomy, including enabling technologies for autonomous systems. And there you can find work on transport systems, including self-driving vehicles, perception, interaction with humans, visualization, multi-agent systems, robotics, autonomous clouds and networks, security, localization, optimization. Overall, we can say that projects in this area have a strong systems focus, and by systems I mean technical or engineering systems. And right now there is quite a strong emphasis on how to best integrate and combine the classical model-based approaches from systems and signals with more data-driven approaches. It's important to have in mind that WASP is not all about AI. Some people tend to believe that, but that is absolutely not correct. So WASP is not only AI. There is a lot of AI in WASP, but not everything. Then we have the AI part, and that consists of 2 parts. We have MLX, which is mostly on machine learning, different aspects of machine learning, deep learning, reinforcement learning, explainable learning, etc., etc. And then we have the math part, which consists of the mathematical foundations of AI and machine learning. Why does a deep neural network generalize as well as it does? Can we have any mathematical explanation for that? Things like that, for instance. There is also work on data analysis and visualization in the form of topological data analysis. And then also the theoretical computer science foundations of AI, they are also included in this. So if you do theoretical computer science, that could fit into this. Then we have software, and by software we mean both software methodology and software technology. However, it cannot be any software project. It has to be a software project that relates to WASP, to the other parts of WASP. So it can be software that in somehow is specific to the research questions that we have in AI and machine learning. So it can be software for modeling, analysis, development, training, verification, deployment of these types of systems. But it could also be software that internally contains or utilizes autonomy, AI, learning, feedback, and so on. And then we have cybersecurity, which, as Danica mentioned, was added last spring as a separate thing in WASP. And there we have exactly the same situation as for the software. It has to be cybersecurity topics that are of relevance to the rest of WASP. Okay, what are the autonomous systems and software PhD students typically doing? Well, a couple of years ago, it was actually before the pandemic, I did a word cloud on autonomous systems and software in WASP and found this. And the big word, of course, is autonomous and system and control and so on. And then I did the same thing for what the AI students typically do, and learning is the big thing, and deep and networks and model and reinforcement and supervised and so on. So it's essentially what you can guess that it would be. Okay, so how do we decide where the project should go? Well, there is an evaluation panel that will evaluate all the proposals coming in, and that panel consists both of industry people and university people. 3 aspects of the proposal are evaluated. The first is the project itself, the scientific level and scientific excellence that this proposal shows. It should be unique, it should be something new. There should be some aspect of visionary thinking behind it. And it should, of course, be of relevance to WASP. Otherwise, it never will get funded. Something which is good is also if the project shows the possibility to collaborate with other WASP instruments and initiatives, like, for instance, the VARA research arenas. However, there will be a separate call, or once the board decides so, there will be a separate call on PhD student projects that are specifically connected to our research arenas. That can be both industrial PhD students and university PhD students, and that will most likely open sometime later this spring. Then the second thing that is evaluated, and that is the PhD student candidate. And since the evaluation panel had no possibility to make interviews and so, it will mostly be what you can, so to say, show on paper that is evaluated. And that is typically the grades from the Master of Science education. But it could also be references from the managers at the company and things like that. And then finally, the supervisors. And this involves both the university supervisor and the industrial supervisor. So what scientific merits do they have? Do they have some international experience, pedagogical skills and merits? Maybe not so important here, though. But what is important is the ability and experience to be involved in collaboration between academia and industry. Have they a good track record of previous industrial PhD students, for instance? And then, of course, also, as always, doctoral students and supervisors with underrepresented gender, they are encouraged. So we very much would like to have that. So these are the 3 aspects that are evaluated. I would say that approximately 1/3 of the evaluation on each of these, I would say. Last year in the call, we had one new thing, and That has to do with the PhD student candidate. The industrial PhD student instrument in general is primarily aimed at students who already are employed at the company. Maybe have been employed for 2 to 3 years or something, 4 or 5 maybe. But they have already learned what is important for the company. They have learned how the company works and so on. But in WASP, we have also quite a lot of small companies, new companies, startups that don't have an internal candidate. In that case, it's also possible to employ a student candidate, especially for this position. And in that case, it is not necessary that the student is employed at the deadline. The student must be identified at the application time, but he or she doesn't have to be employed until the latest start date, which is 1st of January next year. If one do this, there is of course always the risk that the student will change his or her mind and disappear after this proposal has been accepted, but before the latest start date. In that case, the company is allowed to propose a new candidate if that new candidate has at least as good qualifications as the original one. Then it's fine to switch. However, if the student decides to quit after the start of the project, then the project will be terminated. So that could be good to know. So what are then a good proposal? Well, of course, it needs to fit into the WASP research program. It should have a clear and well-described scientific problem and research questions to be solved. There should be some element of novelty, and the proposal should clearly bring forward why the applicants are the best parties to address this particular problem, and also how they complement each other. And then the added value to academia, industry, and Sweden as a whole. But I would say above all, a strong PhD student candidate. That's the most important. If you have further information or need further information and you have questions, you can contact the general email info@WASP Sweden. But you can also contact the university representative group, someone from the WASP University representative group. And here you have the names for the different universities. So Chalmers, Per Stenström, KTH, Bo Wahlberg, Linköping, Michael Felsberg, Lund, myself, Luleå, Marcus Libicki, Umeå, Erik Elmroth, Uppsala, Thomas Schön, and Örebro, Amy Lutfi. We have a Q&A session, but that is not until at the end of this. So I have already actually prepared some questions and possible replies to these questions. So the first question one could ask is, how should we define this project topic? I mean, how long-term should it be? Well, it should be sufficiently long-term so that the results still are of value to the company after 5 years. And it should have sufficient research depth for you to write publication and have them accepted at scientific conferences. So how do you handle deviations then? Well, in the proposal, your proposal is kind of like a plan for what should be done. And very few PhD students end up after 5 years with a thesis that is exactly about the problem that was initially formulated. Maybe they have been forced to deviate for some reason. Maybe it was a stupid original proposal or something. Something didn't turn out the way it should. So deviation, they occur, and everyone has to be aware of that, also the company. What is a good PhD student candidate? Ideally, the student candidate should have a couple of years experience of the company, but still have the graduate education fresh in mind. But as I said, WASP accepts candidates also if they have both shorter and longer experience. Then they should have the ordinary competences that are good for PhD students. They should be analytic, good at problem solving, and they should have good oral and written communication skills. That's very important. Good grades, of course, in particular in courses of relevance. And one should have in mind that many of the WASP courses, they are rather mathematical in nature. So if you have a student with extremely poor grades in all the math courses, maybe that is not such a good idea. What is then the objective for the company? Well, there can be many objectives. One could be that they want to initiate a long-term collaboration with some leading research group in order to improve the company's innovation capacity. Sure. Another could be that they have a very challenging but very, very important problem that they would like to have solved. It could also be that they want to increase the general knowledge area within an area that is of relevance. It could be that they have some very promising employee that they want to give a good competence build-up. Or maybe they want to find persons that should have the sufficient skills and network to take on leading R&D roles after 5 or 10 years or so. Then the company must be aware of the realities of PhD studies. I mean, around 1.5 years is spent on taking courses. Some of these courses may be of less interest to the company and also to the student in many cases, but they must still be taken. And also, an important part of the PhD studies consists of travels to conferences, to network and present results and get inspiration to new research questions. Participating in summer schools to build up the network, to participate in study trips to extend the network also internationally. Meetings of different kinds, for instance, in the different clusters that we have in WASP, in order to discuss research, present research, and learn more things. And that means that, as I said before, the PhD students should have the possibility to travel also if the company has a travel ban. One exception, though, has been the pandemic. I mean, nobody has been allowed to travel during the pandemic, and that has actually been quite problematic for WASP. But we are starting up the study trips now again, so we hope to be up at the same level as before during the coming year. Another question that might be interesting for a company is how one should guarantee that the PhD student remains to be relevant, or what the student remains to be relevant to the company during these 5 years. And it's important that the company sets up a quite well-defined take-up strategy for the results. So that, I mean, it shouldn't be like this, that you send away to the student to the university for 5 years, and then you hope that he or she has something good coming back. That's not how it works. You have to, I mean, one way to do this is to set up some shadow project, some research-related shadow project where intermediate research results can be evaluated and integrated into the company. And also formalize this knowledge transfer, for instance, using regular seminars by the PhD student at the company. And involving the academic advisor can also be involved in this, of course. So that's important. How can we be sure that the PhD stays with the company afterwards? Well, you cannot simply. So far, I said that we had 23 industrial PhD students that were ready. I think out of those, 2 have decided to leave the company. So it's still quite good odds that they will stay. And it's also so that a couple of the academic PhDs that are ready have also joined industrial PhD companies, one can say. Okay, how do we start then? How do you start? Well, you start by identifying the PhD student candidate and the academic supervisor. Often it is good if the university is located geographically close to where you yourself are located. But it's not necessary. It can work still. I mean, here in Lund, at my department, we have one industrial WASP PhD student from Boliden working up in Skellefteå, I believe it is. So it could work anyway. If you don't have contacts in academia yourself, then you can always ask the WASP university representative, and they could then forward you to the right person to talk to. And then start the project discussions as early as possible, because the academic supervisor often knows much better than you do which research problems that fit into WASP and which do not. And then when we started this in 2018, I think, well, we started earlier, but in 2018, we decided to have a special workshop where we discussed all these issues with industrial PhD studies. And there is actually a report from that workshop that you can download and get some more practical hands-on suggestions and so on. Okay, that means that we are done with this part. And then I continue now with a new thing, the industrial postdoc program. So this is, I guess, probably what most of you are interested in. So the industrial postdoc call. This was something that was initiated from the Knut and Alice Wallenberg Foundation last year. And from what I understand, they plan to introduce this instrument in all their strategic programs like WISE and DDLS and so on. Initially, the idea was that this should target newly graduated PhD students that have not yet decided if they want to do an industrial career or an academic career. And maybe then an industrial research career is something for them. So this program should enable the hosting company to get to know the postdoc and at the same time conduct a 2-year academic project. It is the hosting company that applies together with a university research group, and they should be identified, well, they are not called supervisors now, we call them mentors at both the company and university. So it's very similar to industrial PhD student. Industrial relevance and academic quality are the key priorities. And same way as an industrial PhD student, the postdoc should be employed by the company, but the time should be shared between the company and the university. And nominally 50-50, but at least 50% of the time at the university and at least 20% of the time at the company. And I would like to say that if you are a newly graduated university PhD student, then they should actually spend more than 20% of the time at the company, because they already know the university and how that works. So they should learn to know the company more. The reason, though, that it says the way it says is that the WASP board and the Wallenberg Foundation, they also would like to make it possible for persons with a much older PhD exam. Let's say a person that has been working at the company for 5-10 years. They want to make it possible for them to also do an industrial postdoc. So that means that the PhD doesn't have to be performed in WASP, because in many cases their PhD is much older than WASP is. So there doesn't have the PhD degree doesn't have to be performed in WASP. And actually, the company doesn't have to have any prior connection to WASP at all before this proposal. These persons, they need to learn the academic environment much more. So for these, it is maybe relevant to say that they should spend at least 50% at the university. But that, so to say, depends on what the background is. And currently, this call and this instrument has been kind of shaped so that it should fit both of these two types of categories. Okay, and the projects, they should, as I said, address fundamental research problems with industrial relevance within any of WASP research areas. So in the same way as the industrial PhD student project. The total grant that the company gets from, or that you get, is 2.2 million. So it's 1.1 million per year. And out of this, 300K should go to the university and 1.9 million to the company for partial salary funding. If you are an SME, then the total grant is larger and the amount that goes to the company is also larger. And nominally, it's only 5 positions in the first call. And the reason for that is that WASP has no idea how interesting this is for industry, for instance. So we want to go out at the low level and see what happens. And then also, I'm quite sure that there will be new calls coming up coming years, maybe not every year, I don't know, but coming years. And depending on the interest, it could also be that these second and third calls are more narrow in the sense that they are perhaps only targeting new PhDs, or that they are only targeting older candidates. But that is something we don't know yet, so we'll see what happens. Evaluation criteria, well, the academic qualification of the industrial postdoc candidate, he or she must of course have a PhD, otherwise it cannot be a postdoc. The industrial relevance, the scientific level, and qualifications of the supervisors or mentors, as well as their potential to support the candidate and the project. I mean, if we have a very small company, it is maybe not so likely that that very small company should be able to support an industry researcher environment, so to say. So things like that could play in the role. And then also mobility. In the call, it says mobility. To what extent the candidate has changed research group between the most recent university appointment and the planned industrial postdoc. Note, it doesn't say changed university. It doesn't even say change department. It only says change research group. And mobility is extremely important nowadays. I would say that it is more important for the candidates that come directly from university. For candidates that have been working 5 to 10 years out at the company, maybe not mobility is so important, but that's my personal view, and I cannot promise that that will be the case in the evaluation. But personally, I think that in that case, mobility is maybe not so important, because in that case, the candidate is older, has already an established family life and house and everything. It's more difficult to move. And then also, if we have international candidates, which we very well may have, then for work permit and resident reasons, it may be necessary for the applicant to submit an application prior to having the PhD degree. And in that cases, there must be a statement from the PhD advisor saying when the planned defense date is. And more information. Yeah, this is actually not exactly the same list as before, because here we have Robert Felt as the Chalmers person. I don't know, Mickey, what it should be. You can write that in the chat if you want.
Yep.
Okay. Timeline, the call, it's actually exactly the same timeline as for the industrial PhD student call. Same opening and closing date, and the same date for the board decision, and same earliest start date, but the latest start date is actually 6 months later here. I'm not 100% sure why that is the case, but that is the case. Okay, we saved the questions until the end, and now we hand over to Fredrik Heinz to talk about the WASP Graduate School. So now we'll kind of go back to the industrial PhD student program, because the graduate school is not of relevance to the industrial postdocs.
So the mission of the graduate school is to educate PhDs with the skills in strategic important disciplines within WASP, together with a broad knowledge of AI, autonomous systems, and software development. And already here we see that one very important aspect is, of course, that all the PhD students will become very skilled and good researchers in their areas, but we also have this breadth of covering the areas within WASP, which of course is especially important for industries that needs this broader competence as well. So the goals of the graduate school, if we take in the student perspective, is that they should become knowledgeable researchers in their particular area. They should also form a strong sense of belonging to WASP. So we really focus on community building. And one of the consequences of this is that we are favoring physical events. So we want to have physical meetings for the courses. We organize physical trips and so on. So we really believe in that the students should get to know each other and to start to build these networks, which will then be really valuable for them throughout their careers. The students should also get to know Swedish industry. So as was mentioned by Danica, the overall purpose of WASP is to do basic research in order to support Swedish industry in the long term. So getting to know Swedish industry is another important goal. The fourth goal here is that the students should form strong and valuable international academic industrial networks. I already mentioned the importance of community building, and it's also important that it's not only within Sweden and the kind of WASP community in itself, but also to have an international network comprising both industrial and academic people and organizations. And in order to achieve this, we're, for example, organizing these international trips where the students then go and meet researchers at other universities and at companies and so on. And the last goal here is really that we want the students to strive for excellence. So the overall objective of WASP is really this research excellence. So of course, this is also very, very important for the students. And then exactly what excellence means depends on the particular area that you're doing research in, but we want research of the highest quality, and that the graduate schools should support that. If we look from the graduate school perspective, what do we provide? What do we arrange in order to achieve these goals for the students? So first of all, we will organize courses and activities that provide state-of-the-art knowledge in the areas of AI, autonomous systems, and software. We will also organize these courses and activities that actually respect the needs of this very heterogeneous group of students that are also spread out over Sweden. So we know that there's a large variation in the background and in the interests of the students, and also that we're covering most of Sweden. Now that we have Luleå added as a member, we are covering even larger parts of Sweden, which means that we will need to take this in consideration. At the same time, we have this that we want to build these networks, which means that we are favoring fewer but in-person events, for example, for the courses as one example. And as has already been mentioned, as a WASP PhD student, you are accepted to a local PhD program, and this local PhD program provides the formal rules for what you need to satisfy in order to become a PhD. So the WASP PhD program is really added value on top of the local PhD education, and this is exclusively available to those students that are accepted to WASP or affiliated with WASP. So this is really an exclusive added value that's not available to everyone. And last, we also, of course, are really trying to provide opportunities for those that want to excel, which means that we want to have a bit of, for those that really wants to go the extra mile and take on a bit more responsibility or do more than other students, this is something where we should promote and support. So if we look at the activities that we organize, we have roughly 5 types of activities. So every year starts with a winter conference. So the purpose of this winter conference is, first of all, to introduce new students if they haven't been there before. But otherwise, the main focus is for the students to present their research and to get constructive and friendly feedback on their research work. And after they're finished, as a kind of highlight, or not highlight, but at least a grand finale of their PhD studies. They will receive the diplomas. So 2 weeks ago, we handed out diplomas to the students that have finished their PhDs. And I mean, as of now, we have more than 70 PhDs that have defended their thesis. And then after the summer, so usually towards end of August, there's a summer school. So the first year summer school is what we call a community building summer school. And there we gather all the new students so they can get to know each other, learn more about WASP, and to do fun and interesting activity. I mean, solving problems related to the different areas within WASP. And then we also organize more thematic summer schools. So the summer schools this year will be focusing on the research arena. So there will be one summer school on the VARA public safety and one on the VARA media and language that will be organized. We also organize international study trips. So as I mentioned, as one of the goals is to build this international academic industrial network. And to facilitate that, we are organizing international study trips where we take large groups of students to visit interesting places. So last year we had one group going to UK, visiting Cambridge, Oxford, London, and so on. And one group went to Finland and visited companies and universities in the Helsinki area. This year we are planning to visit the Boston area, MIT, Canada, and ETH. So that's what we're planning for this year, students, but so something to look forward to. And normally we organize both trips to Europe and outside Europe as well. And towards the end of your PhD studies, there's also an opportunity to do a semester abroad. So there's extra funding for students that want to spend 3 to 6 months at an international leading university. And here we have agreements with Stanford and Berkeley, and at least those. We also have contacts with MIT, Nanyang Technological University, and a few others, where so either you take one of the universities where we have arranged where we have agreements to have this research visit. You still have to arrange the particular group that you will be visiting and so on, but there is extra funding to do this semester abroad, which again is a further opportunity both for excellence and for international networking. And then we of course organize courses. So this is the fifth type of main activity that we do. So previously there was that all students took the same set of courses. Over time we have added more flexibility and more opportunity to select from a wide range of courses, but there's still a number of requirements. So the main requirement is that everyone needs to take 27 credits of courses. So this is roughly 1 semester worth of courses. So this is very important to be aware of, that you will have to take these courses. Everyone needs to take the only mandatory course that's mandatory for everyone is the course on ethical, legal, societal, and economical aspects of AI and autonomous systems. And I saw that Virginia Dignam, who is the main responsible teacher here, was in the call. So she is responsible for that course. And then we have 3 foundational courses, basically covering the main topics within WASP. And here, every student needs to take at least 2 out of these 3 courses. And the purpose of these courses is really to bring you to the research front and provide a common language and understanding of the area so that you can work in this, and also as a foundation for courses coming later. So here we have courses in autonomous systems, AI, machine learning, and software engineering, cloud computing. So you have to take at least 2 out of these. And then there are the 2 remaining courses. You can either select to take the 3rd foundational courses, or 2 advanced courses. So from the remaining courses, you have to take at least 2. And here we have a growing variety of courses in particular areas such as deep learning, feature representation, reinforcement learning, topological data analysis, and so on and so forth. So providing state-of-the-art knowledge in these areas. For those that have wished to improve their, say, logics background and mathematics background, we also have 2 introductory courses. One is Introduction to Logics for AI, and one is Mathematics for Machine Learning. And the purpose is that these are the knowledge that we expect all students to have. So if you don't have it, we strongly recommend you to take these courses or learn the material on your own, because that will be the foundational courses and all other courses will be based on that. And in general, the introductory courses, the mandatory course, and the foundational courses are given every year, while the advanced courses are given every second year. So if we look at the course schedule, so we have the actually the majority of these introductory and foundational courses are given in the spring, and the reason for that is that most students start in the fall. So this then provides opportunity to directly start and take the introductory and some of the foundational courses, and then there is the autonomous systems course in the fall. And the courses that are given every odd year are deep learning, interaction, collaboration, visualization, which will be given for the first time this year. All the other courses have been given at least once, in many cases several times. So as you can see, there is a broad selection of courses that the students can choose from. I have I mentioned a little bit or several times I've brought up the structure of the courses. So most of our courses are 6 credits, and the normal schedule for a 6-credit course is that there is 3 two-day sessions. So this means that these 3 two-day sessions will be in person at one of the universities within WASP, normally where the main teacher is located, but that they may vary. So this is another opportunity also to see the different university and get a better understanding of what's going on within WASP-related research in Sweden. And then in between the sessions, you work on your own, or you work locally together with your classmates to solve problems or do exercises and so on. So that's the normal structure of a course. So 3 two-day visits. And normally all the dates and the courses will be announced towards, say, the end of the fall for the spring courses, and towards the end of the spring for the fall courses, so that you can plan half a year in advance when it comes to dates and so on. Yes. So to conclude, I really think you should see WASP as an opportunity. I already mentioned this, that the WASP Graduate School is a value added on top of the local PhD program, which means that this is something exclusively available to those that are accepted as WASP students. And we do offer a large variety of different things. I mean, this both meetings, I mean, the winter conference, for example, in Sweden, but also international trips, research abroad, unique courses that are not available otherwise. And so I strongly encourage both you as a supervisor or as a company, but also the students themselves, to see this as an opportunity and really strive to make the most out of it. Thank you very much.
Okay, good. Right. So my name is Pershein. We'll be joined shortly also by Johan Ecker, who will give you a presentation of Ericsson Research, where I did this work. But we'll start from my part while Johan is on his way. And I'll tell you a little bit about what I did in the industrial PhD. I'll first give you a bit of context and how we positioned this work, then mention what of the activities that I were part of. We've heard about them in these presentations today, and then some reflections on the value of the industrial PhD that I attended. So first, this here shows a timeline of the work that I've been doing throughout my career. I started with computer science in 2000 at Lund University, and got my master's there in end of 2004. Already at that time, I came in contact with some of the people that are now working within WASP when I attended courses on AI, computer vision, and adaptive control, and also software. So I had an interest into these technologies already at that time. But after my master's, I went into software engineering, where I worked for a decade roughly as a full stack developer and working as a systems architect and also a Scrum Master. Then in 2014, I got the opportunity to join Ericsson Research in a new field around cloud research. And what we started focusing on there was to look into what we can do in terms of time-critical applications in relation to clouds. We identified already around 2015 that we were going to deliver in 5G, enhanced mobile broadband, with support also for critical communication. This means that we will provide low latency and high reliability that could enable real-time automation and safety critical systems. However, these systems will be connected. And of course, in this environment, we have things like industrial IoT with lots of devices, more or less primitive devices as well, that have access to cloud services. And we figured that we wanted to know more about how we can interact with these services and place the intelligence of these systems in the cloud. So in 2016, we sent an application for a research project within WASP. And this project was going to look into the applications that we could run on what we then refer to as the network compute fabric, interconnected things that can run computations inside our networks. And the idea is that we wanted to understand the impact that we would have on the evolving industries into smart factories and new industries such as autonomous transports and drone flights and so on. Then in 2021, I defended my thesis on control over the cloud. And after that, I have continued inside Ericsson, and I'm now working with our machine learning in the radio access network automation that we're doing. So we'll get back to that a little bit later as well. Okay, so what did I do while I was attending WASP over these 5 years? Well, first of all, when it comes to what I did in my daily work here in Sweden, I of course attended the graduate school. I ran the full course curriculum that we had. I started in 2016, which means I'm part of the first batch of PhD students. This curriculum meant that we would travel around to all the major Swedish universities that were involved and are involved, and have lectures there with very renowned speakers, including inspirational talks. For instance, I think everyone from that time remembers when Richard Murray from University of California held a talk on the DARPA challenge that they attended on autonomous vehicles. This curriculum that I ran got me into autonomous systems, AI and ML, of course, and also software and cloud. We also did projects in groups of students located in Lund, which I think we all found were extremely useful since they all got us in touch with engineering, also those who were academic students. I've also been attending all the winter conferences. These tend to be occasions where we get updates on WASP, but also do a lot of our networking. We do poster sessions and work with the clusters. In my case, we had a cluster specifically on cloud automation. So there we would discuss cooperations between universities and companies involved within the same domain. And we would present our research, of course, and continue socializing with our fellow students. I'm also attending these winter conferences now as an alumni, and I find that to be a really good place to be. Very important interaction with the community. Furthermore, I also worked with the VARAs, the research arenas within WASP. On my part, I did not specifically have research within the VARAs, but I was still there to get involved in engineering projects, work with my fellow students and engineers at Saab, Baxis, Volvo, Senact, for instance. We also came in contact with research institutes such as the Swedish Maritime Robotics Center, etc. And all of this was really very useful in coming up with research ideas, and also we deployed our course projects in these arenas. In addition to the work that I did within WASP, I've also been attending many workshops on cloud control and communication systems in the ordinary daily research that I did. Have been invited to hold seminars at Lund University Chalmers, for instance. Inside the company, I had tech talks to discuss the research that I was doing. And we actually also got some media coverage on the Swedish radio in this work. And then, of course, we also have the international travels within WASP. So outside of WASP, of course, I would travel to present at conferences for all the papers that we produced and published. Unfortunately, during this time, the pandemic hit, so I only attended 2 conferences in person, and then I attended 4 virtual conferences. And these conferences are really, really good to build a professional character, I feel. And it's unfortunate that the pandemic hit, since there's quite a limit to virtual interaction and doing video presentations. You don't get the same practice in presenting and critique and finding research topics and so on. Generally because the interaction in person simply goes further in discussions and takes time to prepare videos and so on instead. However, it was quite useful then that I attended all the WASP international study trips. I went to Europe, USA, Japan, and Singapore on these visits, where we got demonstrations of state-of-the-art research. And we held discussion groups with employees and students at companies and major highly ranked universities and research institutes. And you can see to the right here a list of some, not all, but a large part of the companies and institutions and universities that I visited during this time. Now, in addition to the major companies that we visited and with schools, we also met up with some startups. And for instance, we in California, we went to a farm where a company called Zipline were working on autonomous medical transports of blood packages. And we got to see some of their early operations before this was well known to the outside. They a year later, they presented their work at a really popular TED Talk, and it's nice to have been there ahead of time. 2 of these trips, by the way, were organized by the school, but then we attended 2 more trips in smaller groups where we had to organize these ourselves, something that was possible after building out a network over a few years. And this got us to interact more broadly with the research community and a chance to present our research. When we traveled around on these occasions, we presented at all of the companies and schools that we visited. Right, so the value of this PhD work, where we, the research outcomes that we had from this. Well, if we first look at what we did over the years and go back to this timeline, this picture on the left here shows you a brief view of what we intended with this research. We wanted to connect the 5G networks that we were developing at the time when we started this to devices in the industry, and then connect this to backends running clouds, both in our access network, what we refer to as mobile edge clouds, and also clouds that are connected into our backbone in the 5G environment, and potentially also in the outer world, and use all of these resources in order to improve the devices and what they are capable of doing. So we started this when cloud had established itself in the software community, but we were still wondering how this would be applied in industry and in critical systems. Now, if we take a look at what happened over the years, going back to this timeline that I showed before, but presenting it slightly different, we get this view. So you can see in 2014, we established the idea of doing cloud research on critical systems. In 2016, then, we set up this WASP project and got it accepted. Eventually, in 2021, when 5G now is at its peak, this, by the way, is Google Trends that I'm showing you, if you're wondering. I filed my thesis and defended it. So this came out at a really good time in order for us to continue to working on new businesses around what we're now capable of doing when we combine all of these technologies. And you can also see to the left here that, of course, we got a lot of exposure from the 9 published papers that went into this work, several invited talks, and also around the PhD, we have direct and indirect patents that we have filed. After I defended this thesis, which also evolved quite a lot during this time and came to be about enabling a new generation of systems rather than perhaps looking at how to enable classical systems in cloud. I also continued then into our research organization in leading a research team that looked into new business areas. Okay, and finally, here's a list of some of the value that I found in the industrial PhD, and you can see that there's quite some information here. When I started reflecting upon this, I figured that there's a lot that I bring with me from this time. So first of all, in the research domain, of course, this helps us to stay ahead of the curve. And I think from what I see, what we did, we will, often find that the timing is right when we do this kind of work, even if we're a little bit unsure where it will lead. We definitely are able to build innovation through this and find things like patents and understand how to work with that. It builds values and culture, and through this, I mean also spreading a very positive, culture and values around my company when I interact with people. Also, you get to interact with a lot of talent, really smart and talented people, which provides a source of knowledge and also for recruitment and so on. Also, during the work, I, of course, also had some master thesis students to work with. And in terms of my personal skills, I did develop, even though I have already a lot of experience, I continue to develop advanced engineering skills, I would say. And of course, research skills, writing and presenting, and so on. Also, collaboration, both between the individuals in terms of our research, but also the companies that I interacted with. The research trips really help as well to understand complications also in collaboration and so on, how to be confidential but still productive in these environments. It also helps to drive projects in the sense that, even if the projects here might have been small, you'll have to supervise people, work with scoping them, ensure that we meet timeframes, handle strict deadlines, and so on, and also dealing with stress in these situations. It teaches you to also do lifelong learning, how to find, produce, and deduce knowledge. Let's see. And yes, it also makes you humble to see all of these things that we experienced throughout WASP, builds a professionalism and respect for people and disciplines and so on. And then finally, of course, the WASP network itself. This is a large network with, I now have contacts with my former students around the world, with academia in general, engineers from companies that I've been in contact with, and this also spans internationally then. I also find that the graduate school curriculum was strong and very interesting, helped me a lot to get going. And of course, these platforms that WASP has for collaborations and research, the nests and the varas. I attended varas. Now we also have other opportunities here that anyone who is interested in WASP really should look into and try to work with and use to the best. And then finally, the whole diversity of WASP and everything that you get to see throughout the travels really provides a great awareness, lots of inspiration, and it's really rewarding to be in this community, and it's a lot of fun. And some final words, since you might have seen in the beginning that I did go from the cloud research that I was doing into now working with machine learning. In fact, with our development units in Ericsson. One reason for this is that WASP helped me to get in contact with machine learning and AI again, something that I've always been very interested in. But also, I mean, this change that I slightly did here has benefited from everything that you see on this slide. I have worked with this for half a year, and I would say that all of the values that I've added on this slide is something that I've used through these 6 months. I am directly in contact with my fellow students and others in the community to drive my current work as well. So it's very important, and it's important that I can bridge research and what we are currently doing in data-driven development. Okay, so with that, Johan.
Happy to be here. I think that Per covered this very nicely, and I think that if many of you industrial representatives here are asking the question if this is worthwhile doing, so I'll be very quick in this and try to get to the point, and maybe answer some questions. But I think that the very short answer to if it was worth doing, that it's a very clear yes. For us. And my name is Johan Eker. I acted as the industrial supervisor. As in the academic supervisors the main supervisor was Karl-Erik Orsén at Lund University, and co-supervisor was Maria Kiel. So the four of us worked together for 5 years in this. So Per, if you just skip ahead to my third slide, I don't think we need to introduce Ericsson in this, but the next one here, that guy, yes. So the way Ericsson research on Ericsson works is that we are kind of, with the 1G, 2G, 3G, pretty much with 10 years in between. And when Per and I started to work on this was in 2015, around planning for this. And that was, of course, when 4G was released and we were planning for 5G, and we were looking into digitalization of societies and industries. How can we use network to explore new business areas, and can this technology that we are developing be used for more than supporting the app economy and so on. So this was a kind of thinking 10 years ahead from where we are right now, and then having Per being away or being very heavily connected to the university for a couple of years was a good way to educate ourselves and broaden the horizons. So Per, hit space. Oh, so this is called sort of the era when we're kind of Per came in and we were looking into new applications for our mobile networks. So next slide, please. So in very short, answer to the why, I think it's one way extending our horizons, both mentally, what can be done, but also look further into the future than you might be able to afford even if we have a very strong research group, the academic time horizons is still longer and wider. And that was a way for us to explore new business directions. When Per went into this, 5-6 years ago, this was not a novel area. And when he comes back, it's actually become a very concrete business area for Ericsson. And the competence that Per is bringing back is highly valued. I think the main thing is networking, not just for us as supervisors, but also for the network that Per brings back. I mean, imagine that he's now they have over 400 PhDs in WASP, and of course he knows many of them, and that's extremely valuable for us as a company. We educate ourselves. We have access to the best of the best, both in in courses taken, but also in supervision and so on. So it's a way for us to be on par with the competition. I think also a good thing with this is contributing and being good citizens. We try to give away of our expertise and be working together with universities. Very rewarding. It also gives us a way to influence research and education. Being a speaking partner has been very valuable, and I think that there's been a good exchange of ideas. Recruitment, not only we get to keep Per, but we have met other students, and we have employed quite a few students during the years from Control and WASP. So and then finally, it's inspiring and fun. Yeah, I really recommend it. And I think I think this is a main slide. Now we have 5 minutes left for this half hour, so I would encourage people to ask questions to me, Per or Karl-Erik, or anyone else who can. So thank you.